very warm welcome to everyone. Today we will be learning one of the most important topics, that is algorithms. Even the language changes, the syntax might change, but the logic for these algorithms will remain same. So today we will be learning the importance of an algorithm, different types of search techniques, which includes linear search and binary search, and time complexity for each of these cases. We will also look into sorting techniques, which includes selection sort, bubble sort, and insertion sort. We will also look into time complexity of each of these techniques. At last, we have some practice questions for you all. Before getting into the topic, let's revise what is an array. It is a collection of similar data types that are stored in a memory location and can be accessed randomly using index value. One of the most main advantage of this array is code optimization. We know how to declare an array. Here, phi indicates the size of an array. Index value starts from 0 to n minus 1. So here, in this array, 1 has index value 0. Similarly, for phi, we will have index number 4. Now, if you have basic understanding of array and conditional statements, you are good to go with searching and sorting techniques. Algorithms. These are the predefined steps that are used to find a particular solution. We have two types of algorithms, searching and sorting. Searching is a process of finding a particular item in a collection of items. Let's say we have 1, 2, 3, 4 in an array, and now the user wants to find number 3. So here, searching will help you. Sorting is a process of placing elements from a collection of same kind of order. So when you have a cluster of elements that are present in an array and you want to assign them in an ascending order or descending order, then we use sorting techniques. Let's start with searching. Searching is mainly of two types. First is linear search, second is binary. Linear is sequential search of an algorithm. Binary, it works repetitively by dividing of an array. I know this won't make any sense, so let's dive deeper into it. Linear search. It is a very simple search algorithm. Sequential search is made all over the items one by one. Each item is checked, needs to be found. So by writing the logic for linear search, the compiler will start from 2 and go till 7. So it will iterate from 2 to 4, 4 to 5, 5 to 6 and 6 to 7. On its way, it finds number 5 present in index number 2. So this will be returned. The same thing has been written in algorithms also. It will set I is equal to 1 and will iterate one by one. And then if the element is found, it will return the value. If not found, return nothing and then exit. Let's take another example. Let's say we have 1, 5, 2, 7, 8, 4, 3 and the key given is 4. So what will be the expected value? First, let's write the index value for each element. For 1, we will have 0, 1, 2, 3, 4, 5 and 6. Now for key 4, the compiler will first go to index number 0 and then will iterate 1 plus 1. On its way, it will find 4 that is present in index number 5. So you're right, the output will be match is found at index 5. Let's check the time complexity. Always remember, for a good program, time complexity plays a major role. It is defined as the number of times a particular instruction is executed rather than the total time taken. It also depends on factors like compiler used and the processing speed. So according to you, what will be the time complexity for linear search? Time complexity for the linear search is O of n, which means when the compiler starts searching, it will iterate through n number of elements that are present in an array. So therefore, the time complexity of a linear search becomes O of n. Try and execute linear search program on code blocks. Here I have initialized some variables n, I, j and key. Here key will play an important role. I've also predefined the size of an array max to 100. Now let's try to understand the logic of linear search. First, we will ask the user to enter the key value that needs to be returned. We will scan the key value. Now the for loop will be executed. It will start from I is equal to 0 to I less than n, which means it will start executing its code from index number 0 to index n minus 1. It will iterate by plus 1. It goes into the if loop and it will check if the condition is true. A of I is equal to key. If the key value is found in the array, it will return the index value, that is I. Now let's try to run this program. It is asking for the size. Let's say 4. Now it's asking to enter the elements 3, 2, 5 and 4. Now see, it's asking for key value. Let's say I'll enter element 2. Element 2 is found at index 1. This is how linear search works.